Hey, welcome back to RamZland. Today I want to use elemental cesium to synthesize cesium sulfide. Check this out. Cesium is an alkali metal. It has 55 protons. It's extremely hygroscopic and very reactive. It was discovered in 1860 by Robert Bunsen and Gustav Kirchhoff. Now I realize the francium is more reactive than cesium, but on any given day, there's really less than 30 grams of francium on the planet. Further, its half-life is only 22 minutes. And so cesium is probably the most reactive alkali metal that you can actually interact with. So one of the things that I think is so special about cesium is that it can be a liquid at room temperature, just like mercury or gallium. And so if I just warm it up in my hand, it'll start to move through this glass ampule as a liquid. And I want to show you what that looks like. So it's starting to melt now. You might be able to see it move through the ampule. Let me warm it up a little bit more in my hands. And then we're going to put some mineral oil in this container next to me, and that way we can open the ampule safely in the mineral oil, because cesium is extremely hygroscopic and it'll try to absorb water right out of the atmosphere. You can see that it's behaving as a liquid now inside the ampule. Isn't that fantastic? So once we have the cesium safely in the mineral oil, we'll take very small amounts of it. I think we'll add some to water to synthesize cesium hydroxide, and then we'll take a very small amount and add it to molten sulfur to make cesium sulfide. And I think that you'll find that rather spectacular. Look at the cesium move through the ampule. Just a beautiful alkali metal. Okay, so I'm going to first pour some mineral oil into our container, and then we'll add our cesium ampule, and while it's in the mineral oil, we'll crack it open with a pair of pliers. Okay, so now our cesium is safely out of its ampule, and you can see that it's gone from that bright gold luster to kind of a dull gray as an oxide layer has formed on the outside of the cesium. Now, since the cesium is such a soft alkali metal, I should be able to use this spatula to cut a very small piece of cesium and add it to this petri dish of water, and that will create hydrogen gas and cesium hydroxide. Now, the hydrogen gas is going to get so hot in this exothermic reaction that it'll be ignited by the heat of the reaction as the hydrogen is liberated from the water. Check it out. This created cesium hydroxide, so I'm going to use phenolphthalein as an indicator. And when it's in water, if there's a pH of 7 or less, if it's an acid, it appears clear. So I'm going to swish it around my beaker of water, and you can see it's clear. If this did create cesium hydroxide, it should turn pink in the presence of phenolphthalein. So let's find out if that's true. Oh yes, there's our bright pink solution. Evidence of cesium hydroxide. And at last, I'd like to synthesize just a little bit of cesium sulfide. We're going to take some sulfur and we'll melt it into this ceramic crucible, and then we'll add a very small amount of cesium. Check it out. Okay, now we're ready to start heating it up. here's our final product, cesium sulfide. Let's take a look at the equation for this synthesis reaction. We started by melting elemental sulfur, that's the S, that's our first reactant. And then we add the reactant cesium, CS, and that creates the product CS2S, cesium sulfide. I hope you enjoyed today's edition of RamZland, and I'll see you next time. If you enjoyed this presentation, be sure to remember to like and subscribe.